So this video is going to continue on with our how do we handle addition and subtraction of radical expressions set of examples here. So we're looking at the quantity fourth root of 81x to the sixth times y to the third minus the fourth root of 16x squared times y cubed. So how do we go about simplifying this? The idea remains the same as it has across all of the examples we've done so far, where we want to cluster everything into powers of 4 and simplify each of the radicals independently, and then hopefully we'll be able to factor out something useful later. So how do we go about doing this? First thing we want to do is start breaking down the first and second radical. Notice that I have an 81 in here. I'm going to use a factor tree to break that down. So I have 81 broken down into 9 and 9, and that breaks down into 3 and 3, and 9 breaks down into 3 and 3. So here we have 4 3s, and that'll be helpful because then we can cancel out the radical, the fourth root here, once we go and use the product rule for radical expressions. Similarly, let's take care of 16. So if I'm looking at 16, that breaks down into 4 and 4. 4 and 4 break down into 2 and 2, respectively. And now I have clusters. I have a cluster of 4 2s as well. So we'll be able to cancel out this 16 as well to some extent, simplify that a little bit. So rewriting, just using our factor tree information, we have fourth root of 3 to the fourth times x to the sixth times y cubed. Okay, and then we're going to break down the 16 into a power, so we have 2 to the fourth times x squared times y to the third, and that's the fourth root. Okay, so far so good. Let's break this down using the product rule for radical expressions. So we have fourth root of each of these guys. So we have fourth root of 3 to the fourth times fourth root of x to the sixth times fourth root of y to the third minus, okay, now we're going to have to handle this term. So we have fourth root of 2 to the fourth times fourth root of x squared times fourth root of y to the third. Okay, so now how can we, now looking at all of this, we've completely broken down everything using the product rule for radical expressions. Now, how do we break each of these guys down? First thing we notice, just basically reading left to right at this point, fourth root of 3 to the fourth, those cancel out, just leaving us with 3, okay? Now this fourth root of x to the sixth, I can cancel out some of these x's. How many? I can cancel out exactly 4 of them. I just need to rewrite this first as fourth root of x to the fourth times x squared in this case, okay? So the idea is I'm breaking things down into clusters of 4 so that if I use the product rule again, I can cancel off this x to the fourth using the fourth root. So continuing along here, I have 3 y's in here, but I need 4 of them to cancel the root. So I'm going to be stuck with this guy. Now onto the second term. We have fourth root of 2 to the fourth. The 4 and the fourth root cancel out. That gives us just 2. Then I multiply by fourth root of x squared. So we're probably going to be stuck with this guy as well. You can also combine this so that you get y to the 1/2 power, or square root of x to the 1/2 power, or square root of x. But I think we're going to leave this as is for the time being and simplify that later if necessary. But in this case, in this term, I have fourth root of y cubed. So this doesn't have enough y's in it to cancel the fourth root, so we're stuck with just that. We have fourth root of y cubed. Okay. Using the product rule, again, we're just reading left to right like a typewriter at this point. We have 3 times, okay, we're going to use the product rule and break this down as much as possible. But I'm going to skip a step here because you guys have seen a lot of examples at this point. You probably don't need the extra step. So I have a fourth root of x to the fourth. That just leaves us with an x. And then we're left over with 4 fourth root x squared. But here's the thing. I think it's an x. However, since I have an even root and an even power, we don't quite just get x, because x could be negative. And if I take a fourth power of a negative, I get positive. And if I take the fourth root of that, I'll still have a positive number. So this needs to actually be absolute values of x. Okay? All right, so that's important. That's really important that you make sure you have the absolute values there. Okay, so we have that fourth root of x squared that came from this guy. And now I'm going to have this fourth root of y cubed. I just carried that along. Let's see if we can do something similar over here. We probably can't, because I have a fourth root of an x squared, so I'm stuck with that. And I have a fourth root of y cubed. I'm also stuck with that. So, okay, what do we do at this point? I have a 3 times the absolute value of x, and I have these two fourth roots, both of which can't be broken down. So I'm going to recombine them, put them back all under the same radical, and I'll do the same thing over here because I have the same thing over here. So I have 3 times absolute value of x times one big radical, fourth root of x squared times y cubed. Okay, we're going to do the same thing in the second term. So we have minus 2. Put this all under one giant radical. I have x squared times y cubed here. Okay, so we've handled everything that we could. We just put all these guys under the same roof. And maybe we can distribute or add or factor in this case. So I'm looking at 3 absolute value of x's, 3 absolute value of x of these guys. I have minus 2 of these guys. So how many am I going to have in total? It's just going to be combining the leading coefficients here. Or, if you like, you can factor out these guys. Whichever way you prefer, or whichever modality of thinking you prefer, they give you the same thing. So they leave you with fourth root of x squared times y cubed times the quantity. I like using square brackets when I'm factoring out big stuff. Times 3 times x absolute valued minus 2. Okay, so now if I were to FOIL this back through, take this and then distribute it to each of these guys, I should get back exactly what I had to begin with. So you can always double check yourself to make sure you did your factorization correctly. So in this case, we're done. These can't be really combined anymore because of this absolute value of x sitting here. Nor can this be simplified because we can't break down x squared into powers of 4, and we can't break down this y cubed into powers of 4. So we're stuck with this guy as well. So for all intents and purposes, this example is done. So if you found this helpful, awesome. Leave a comment if you're watching this on YouTube. And yeah, I guess I will see you in the next one.